So here's my question. Did you have x over sine 102 equals 6 over sine 54? Oh, you switched them up. Okay. Now, by the way, could I set this up? Second. Could I have set this up with the 6 and the x on top? Yes. As long as I do something to one side, it's okay. As long as I do it to the other. Could I flip both sides and it's still all right? Yeah. So, hey, Hunter, sorry, forgot to log in earlier, buddy. Okay. Now, so let's go ahead and number two. Number two, what's our setup here? Or what do you want to do first? I don't care. What do you want to do first? You want to find x. How come I can find x super fast, Meadows?
Because there's two numbers?
Yeah, I already got two angles, so all I got to do is find a third one, right?
Yeah.
So that's 100, it's 136. What's 180 minus 36? No, I'm sorry, 136, sorry. Is it 44 degrees? Is that what everybody got? I get that. Okay, now where's my best way to start to find either z or y? Where's my pair? What is it? Yeah, sine 105 over 12 equals, which one do we want to do? Y. So I'm going to say, oh yeah, okay, cool. Yeah. Sine 44 over y. Now, how come I can be pretty confident that this is going to come out okay and I'm not rounding badly? Because that 44 is straight up, right? Yeah, there's no rounding there. So could I cross multiply and solve? And I bet that I get somewhere around 6.5. I don't know, what is it? Let's find out. 12 times sine 44 in parentheses divided by sine 105. Answer is 8.629. 8.629959. Now, how do we get that, guys? Cross multiply, right? So what I end up with is y equals 12 times sine of 44. Does everybody agree with that part? And then I would have a sine 105 over here, but I'm going to move it, so I'm going to divide by sine 105 when I move it across. Do you agree? Now, these guys are about $14. Okay, these calculators are about $14. You can totally do this on your phone, but have you figured out yet that doing it on your phone is a real pain in the wazoo? And especially if you're a junior that's taking the SAT next week, that one of these would probably be a good investment for about $14, because any science or any math class that you take, could you pretty much use this calculator and be good to go? Yeah. Even if you go to college, like to Richland for childcare, they got to do teaching childcare for math, okay? Or teaching math for children. They'll use a calculator, something like this, okay? So $14 is a reasonable investment if you can afford it. Now, what is my setup for the other one? This is where it's a little bit different than this one. I'll make sure we get this right. How do I set up to find z? What do I use? Would I use this pair? Because there's no rounding there, correct? And then this pair to find z. Do we agree? Is there any chance I'm going to round it badly as long as I'm careful? I think we're all right. Now, how come over here I don't have to worry too much about rounding? How come for number 5, I don't need to worry too much about rounding? There's a right angle, so that's 90, correct? How do I find y again? What do I know? 2 and what is this side? Opposite, this is. And because it's a right angle, I can just say sine of equals close, 2/6, right? How do I get rid of the sign, folks? Close. We don't divide by sign, but we take the inverse sign, right? It's sine -1 now. So can I say second inverse sine of 2 divided by 6? Boom. And it gives me 19.47122. At some point, if Delta Math asks me, could I round that to the appropriate place? Now, how do you find x here? There are two ways. One of them is better than the other. Oh, Schnooker. Mr. Moore. Hello, I will get that attendance in. Bye. Schnooker. Any. Okay. I know. Here we go. Here we go. Skyward. All areas. Come on, little buddy. You can do it. Grade book. Hanny is absent. Hinton was tardy. Scales, Ozzy, Osman, those are all remote. Massey is absent. But everybody else, we see their bright and shining faces. Okay, cool. All right, back to where we were. All right, has somebody figured out how to find x yet? What is it? How did you get 70.53? Okay. 180 minus 90, because we got 90, minus 19.47, blah, 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 blah. That is a way to find an answer, isn't it? Is that the best way to find an answer here? No. Because if you screwed this up, guaranteed what just happened up here. I guarantee it's wrong, right? Let's go a different way to find x that even if I screwed this up, would not affect that. Yeah. Could we do this one and say, oh, that's adjacent and hypotenuse, and now is y connected in any way to x? So even if I get one wrong, I can get the other right. Now, here's a really good thing about this is, what if I do get this wrong, and then I find this answer, and I look at all three of them and go, wait a minute, that doesn't add up to 180. Then what does that tell me? It means one of the two of those, I don't know which one yet, but I know one of the two of them is wrong, correct? But if I straight up subtract it from 180, I don't know if anything's wrong because it wouldn't pop up at me. Does that make sense, guys? Now, here's the big one. Here's the big one. This one, unfortunately, there's almost no way to not use a rounded number here. How come? I don't know any angles. Now, what am I going to have to do if I have no pairs? What law am I going to use? Law of cosines, correct? So, which angle do you want to find, x, y, or z? You want to find y, okay? So that means y goes down here, and that means 7 goes down here. Does everybody agree with that? Because the two pairs have to be on the ends. What goes in here? What goes here? Perfect. 2 times 8 times 13. There you go. Now, this is also where we have to talk about rounding, right? Is it too bad to get 64 and 169? Could I put those two together without rounding anything at all? And could I subtract it from 49 without rounding anything at all? So here's what I'm going to do. I'm going to say 49. Everybody agree? Minus, what's this? Minus, okay. And I get negative 184 equals negative 208 cosine y. Does everybody agree with that? What do I do now? What do I do now to get the y by itself? Guys, what do I need to do to get the y by itself? Get rid of the, yeah, 208, correct? Now, is there an opportunity for me to round this? When I take 184 divided by 208, I get an icky decimal. Do you agree? What can I do to help myself to not get this problem wrong? Could I write all those little numbers? Could I do that? Or maybe even if I just wrote that many numbers, would that help me? Equals cosine y. Now what do I do to get y? Second cosine inverse of that answer. 27.7957. Does everybody agree with that? Okay, that's one angle. How do you find the other two angles? How do I find the other two angles? Well, I have two ways. You ready? I have two ways. One of them is better than the other one, but not a ton better. What's one way I could solve for x? Could I totally do this law of cosines again? But this time, if I want x, what goes over here? 13. 13 squared equals 8 squared plus 7 squared minus 2 times 7 times 8 times cosine of x. Could I do that? That's the best way because I didn't use my answer here, did I? Do you really want to do 3 laws of cosines here? It's a lot. I'm going to be honest, it's a lot. But would it be the most accurate? Probably. What's the other way that's almost as good? Oh, you totally could. Okay, so she says law of cosines twice, and then subtract from 180 to get this. Again, it's a way. Is it the best way? No, but it's if you use lots of decimals, could it be okay? It could be, couldn't it? So actually, there's 3 ways. You came up with a way I didn't even think about. Could I use law of sines here? Do I have a pair now between those two? Now, what's the only problem with using law of sines and using the 27.7957? It's A, it's a lot of numbers. B, what if I screwed this up? What will automatically be true about my next answer? Guarantee it's wrong. But if I was very careful here and I use lots of decimals, could it be okay? It could. All right, that's what I want to talk about with you today. Hopefully you understood the basics of law of sines and cosines from yesterday. And then today, do you see how we need to put a little bit of finesse on it? It's like watching a 5th grade ball team. If you go watch a 5th grade ball team of any type, yes, they're in basically the right positions, and yes, they're basically doing the right things, but it's ugly, right? If you go watch a team that's been together and has some more years of experience, they're still in the same spot, they're still doing the same stuff, but are they doing it hopefully a little better? Get the idea? That's what we're going for here. What is your homework for the rest of the day? Well, let's see here. We've already done 1, 2, 3, and 5. All you have to do is finish number 3, which you should already have done, and do number 4 and 5, correct? Now, let's also talk, because I don't see you again until what, Monday? Yes, no, maybe so? No, yeah, Monday. Okay. So here's the other thing I need you to do. Oh, hurry up. Okay. For Monday, law of signs, I want you to get started on these dudes right here. So for Monday, you need to do the remaining 2 problems. Those should be done by the end of the day, and do these 3 delta maths. Okay? And in fact, we'll just make those do, let's make those do Tuesday, the 13th. Okay? Can we do that? Now, ideally, should you have these good started and almost done on Monday? I would hope so. Okay, but I'm not going to be able to put in grades on them until the B-Day kids turn them in. So there you go. That's the idea there. Do Tuesday, do Thursday, do Tuesday. Okay. And then we're ready to go to the next chapter. So we'll deal with that next time. Okay? That's your homework. Go, go, go. Hunter, do you have any questions? Nope. All right, buddy. See you later.